In this unit, we're going to look at measuring heat, looking at how much heat comes out of a reaction or how much heat is drawn into a reaction. Let's think of a process that involves a change in heat, an obvious change in heat. An ice cube melting. So what do we see? What do we see when an ice cube is melting? Solid changing into a liquid. We feel cold as we hold that ice cube in our hands. So at the particle level, what do we imagine is happening with these water molecules? When you have a solid, they're all linked together in this crystalline shape for the ice. And as we change to a liquid, now this liquid is not as structured. The molecules are moving. They're still stuck to each other, but we've got a liquid. Now, in order to get the ice cube energized enough to start flowing, heat has to go in. So here's an ice cube. You can imagine holding it in your hand. You can feel warmth leave your hand and go into the liquid, and it feels cold. And as we imagine the particles, the ice has our water molecules locked in place in a crystal. The heat goes in, and then the water molecules start moving around. Now, when we imagine the math or the measurements of what's happening, we can plot an energy diagram. And all I'm going to do is draw an x-axis and a y-axis. The y-axis measures the level of energy of the system. And our system in this case are these water molecules that are all linked together. And as a solid, the system has a low energy level. On the x-axis, we have the process from start to finish. Now, in order to get the ice to melt, the energy level has to go up through the process. And as it melts, at the end, we have our liquid, but the particles are more energetic. So our energy level went up. So whenever we measure heat or we measure changes in energy in chemical reactions, we're always asking the question, did the energy level go up or did the energy level go down of whatever it is that we're defining, whatever system it is we're looking at? And mathematically, the symbol that means change is the triangle, is delta. So in this case, there was a change in heat or a change in enthalpy. That's a new word we're going to use a lot. The change in heat was positive because the heat or the energy in the system increased as it changed from ice to liquid. Okay, so ice cube in my hand, melting. The ice itself is getting more energetic as it turns into a liquid. The particles, we can imagine the crystal. These molecules are not moving as fast. When we add heat and it changes into a liquid, they're now more energetic. So we can model the particles changing their motion, changing their structure. And then as far as the math goes, we've got energy change that we can measure. Either the energy is either going into the system or the energy is coming out of the system. Now, remember that we're analyzing the system, okay? So if this is our water, ice to liquid, this is our system. This is what we do the math for. This is what we're modeling. But the surroundings are what we measure. I can't get right directly into the system. I can only measure what's coming out or going into the system. So if I have energy going out of the system, and the system starts out high and then gets low, the energy of my surroundings goes up. So if the system loses energy, the surroundings gain energy. If the system gains energy, the surroundings lose energy. Okay? In this case, as the ice turns into a liquid, it's drawing energy in so that the ice cube can have its molecules start moving, so the surroundings, which is my hand, gets cold. The system gets hot. So if what I'm touching is drawing energy in, then for me, touching it, I feel cold. If this was a hot pack and the chemical reaction was releasing energy, then the surroundings would get warm while the system gets cold. So that's the basics. Those are the basics of how you measure heat.